In this lesson, we're going to learn about linear functions and the way we can represent them in equations. We'll look at slope-intercept form, point-slope form, standard form, and a few others. Let's talk about slope first of all. Linear functions are associated with having a constant rate of change, which is called slope. There are 4 states of slope. Let's start with the graph on the left. We have a positive slope. As we read our graph from left to right, our graph is going up. It is positive. When we read a graph from left to right and we go down, this is called a negative slope. When our graph neither goes up nor down, but just is constant, that has a slope of 0. And then when we have the vertical line, we call this slope undefined. Slope is a ratio that compares the vertical change to the horizontal change. This is also known as rise over run. Let's take a look at this graph and find the slope. Now, when we work with slope, or we're working with a graph in general, we read them like we read a book, from left to right. So we're going to start with a point to the left and work our way to the point on the right. Remember, slope is the rise. It is the vertical change. So we're going to ask ourselves, how did we get from this point to this point? First, vertically. So we are going to go down 1, 2. So that's -2. And then the horizontal change, the run, is going to the right, 1, 2, 3. So we had a rise of -2, a run of 3, and this is our slope. And we do use the variable m to represent slope. Now let's take a look at 2 other points on this line. We could take a look at this point and see how we're going to get to this point using rise over run. So we're going to go down 1, 2, 3, 4. And then we're going to go over to the right, 1, 2, 3, 4, 5, 6. So that was a run of 6, and this simplifies to -2 over 3, just like we had the first time. So it doesn't matter which 2 points you use, you're always going to get -2 over 3 once you simplify. That is why slope is a constant rate of change. So we were going down to right 3, down to right 3, down to right 3, down to right 3. A constant rate of change. And remember, always find your rise first, which is the vertical change, and then the run. So if we go down, that is negative. If we go up, it is positive. And because we're going to go right each time, because we're working left to right, that is a positive change. There are 2 things that we need to make sure we know about linear equations. We need to know that they do have a constant rate of change called slope, and we need to know that formula. That way, if we're given 2 points at the line without a graph, we can still identify the slope with this formula. The other main idea we need to know is that all the points on that line, if plugged into the equation, would give us a true statement. Let's test these 2 things out. Here we have a line that passes through -6, -4, and -2, 2. We want to find the slope, or the constant rate of change, between these 2 points, and we don't have the graph. So our first coordinate, we have x1, y1, and then we have our second coordinate, this is x2 and y2. And now we're going to plug those into our formula to find the slope. So we have 2 minus -4 over -2 minus -6. When we simplify this, we get 6 over 4, which simplifies to 3 over 2. We have a constant rate of change of 3 over 2. So this line slopes up 3, right 2, up 3, right 2. And so we would have a line if we had our coordinate plane. Now the second point is that if this line passes through this point, once I plug this point in and do the math, I will get a true statement. Here's our x value and here's our y value. Let's plug those in. Make sure you use parentheses when you're plugging in, especially when you're dealing with several negatives. Now we're going to do order of operations. Negative times a negative is positive. And then I subtract, and I do indeed get a true statement. This means that this point is part of this line. 3 of the main equations for linear functions is slope-intercept form, which is the most user-friendly because we can graph them easily because we know the slope and we know the y-intercept. Then we have PointSlope Form, and this is useful to get slope-intercept form if we know a point that's not the y-intercept and we can identify the slope. So we have a point on the line and we know the slope. Then we have standard form, where both the x and y variables are on the left side and it is equal to a constant. Then we'll look at some special lines, the horizontal line that we looked at earlier that has a slope of 0. That would be y equals some number. And then we have the vertical line, which would be x equals some number. Remember, the horizontal line would have a slope of 0, and the vertical line, x equals some number, would have a slope that we would say is undefined. Let's start out with slope-intercept form. It's the most user-friendly, like I said. We can graph easily. So when we have y equals, and y is isolated, and we have mx plus b, so we would have a value for m and a value for b. M is the slope, the rise over the run. Our b value is the y-intercept, where the line crosses the y-axis. And if we were to write this as an ordered pair, it would be when x is 0. So it would be 0, b would be the ordered pair. And this value, the y value, is our b value for our equation in slope-intercept form. Let's take a look at this example. We have a linear graph, and we're going to write it in slope-intercept form. We need to locate 2 points on this line. We can pick any 2 that we see. So here's a point, and here's a point. We're going to find the slope first, which is rise over run. Again, I want to work from left to right, and the rise is my vertical change. It's up or down, so we're going up, so we have a positive slope. So it's up 1 and to the right 2. Up 1, right 2, up 1, right 2. So my slope is 1 over 2. The y-intercept is the point where the line crosses our y-axis. This is going to be 0, 2. And when we put this together, we're going to fill in m with 1/2 and b with 2. We have y equals 1 over 2 times x plus 2. Let's take a look at a second example. We're going to find the slope. Rise, which is the change of the y's, over run, the change of the x's. Here's a nice point on the graph, and here's a second one. So the rise is going up 1, 2, 3. Go ahead and write that, 3. And the run is 1, 2, 3, 4. And it is simplified. The point where the graph intersects the y-axis is 0, -3. This is the b value, and this is the m value, and we put it all together. y equals 3 over 4x minus 3. Now let's look at an example where we want to identify the slope and the y-intercept, and we're not given a graph, and it's not written in slope-intercept form because the y is not isolated. This is actually standard form, and we need to get the y by itself to say y equals some number times x plus some number. Let's go ahead and subtract our x term, bring down a positive 2y. I'm going to put my x term first. Now we just need to divide each term by 2. I get a slope of -2 and a y-intercept of 3. So if I wanted to identify these components, I would say -2. And if I were graphing, I would put a 1 underneath. That means I'm going down 2 and right 1. My b value, my y-intercept is 0, 3. So I could graph this very easily, starting at 0, 3, going down 1, 2, and right 1, down 1, 2, and right 1, and we get an idea of what this graph looks like. In this example, we have been given the slope and we have been given a point, and luckily for us, that point is the y-intercept because it's when x is 0. So we know the b value and we know our m value. We put it all together, y equals 5x minus 6. In this example, we don't know the slope, but we do have 2 points, so we can find the slope using the slope formula. So let's recall the slope formula. Y2 minus y1 over x2 minus x1. Let's go ahead and label these values. This is our first coordinate that's given to us. This is our second coordinate. And now let's plug in. We have -1 minus 3 over 0 minus 2. We get -4 over -2. That gives us a positive slope. Now remember, when x is 0, this is our y-intercept. This is the b value. So we can put this all together and say y equals 2x, our slope, minus 1. Here's an example, another one of where we have 2 points. We don't know the slope, but we can find the slope. We have x1, y1, x2, y2. So therefore, we have 4 minus 8 over 0 minus -2. That gives us -4 over 2, which is -2. And again, luckily for us, they gave us the b value because x is 0. This is where it crosses on the y-axis. So we have y equals my slope of -2 and my y-intercept where the b value is 4. Now let's look at point-slope form. Point-slope form is we have one point and we can identify the slope. This is useful if you're given 2 points and one of those points is not the y-intercept. We can put it in point-slope and then manipulate it to slope-intercept form. Let's take a look. Find the equation of a line with a slope of -1. So my m is -1. And then I have a point x1 and y1. So here's those values. So my x1 is going to be -4. My y1 is 6. Now let's just plug in to all of the parts of our formula. We have y minus. My y1 is 6 equals my slope of -1. And then it's x minus the x value of -4. So be very careful because these are subtracts here. Be careful when your values are negative. Now let's clean this up just a bit. And this is point slope. But it's not very useful, but we can convert it to slope-intercept form. So I am going to first distribute the -1. Now let me just remind us of slope-intercept form. This is the goal here, right here. So I'm going to distribute this -1. Now I just need to get the -6 off of the left side, so we're going to add 6. And I have y equals -1x plus 2. So my slope, as we knew, is -1, and my y-intercept is 0, 2. Here we have 2 points of a line, and we don't know the slope, and we don't have the y-intercept, so we can use point slope. So I'm just going to choose one of the points to be my y1, x1. I'll probably just choose the first one. But before we do that, let's find the slope. Anytime you have 2 points, you can find the slope. So always know that you can start there. We have y2, -6, minus y1, -8. Again, be careful with your negatives. Over x2, -4, minus x1 of +4. This gives us a rise of 2 and a run of -8. But when we rewrite this, I'm going to bring the negative up to the top, and I'm going to simplify this to -1/4. Anytime I have a negative that's in the denominator, I like to put it with a numerator. And that way I'm going up or down. In this case, I'll be going down, but I'll still be going to the right. So this is going to be going down 1 and right 4, having a negative slope. Now, let's use PointSlope Form to find my y-intercept. So first of all, I'm going to use this first pair to be my values for x1 and y1. So be careful as you're plugging in. Do not get in a hurry. So I'm going to have y minus my y1 is -8 equals my slope that we just found of -1/4. Then we have x minus my x1 value of 4. This is point slope form. Now, let's get into slope-intercept form, and all we need to do is first distribute my -1/4, and now we need to get the 8 off of the left side, so we're going to use the subtraction property of equality. So if we were asked to identify the slope, my slope is -1/4, and my y-intercept is 0, -7. And I could graph this very easily. I would start at -7, and then my slope is down 1 and right 4, and down 1 and right 4. So this gives us an idea of a quick sketch of what the graph would look like. Let's do a couple more. We have 2 points that this line passes through. We don't know the slope, and we don't know the y-intercept. We're going to use point slope, this form right here, and then we'll convert it to slope-intercept form. So finding slope is the first thing we'll do. -3 minus 6 over 1 minus -2. I get -9 over 3, and that gives me -3 for my slope. Now I'm just going to use this first ordered pair to be the values for y1 and x1. Again, I'm going to be very careful plugging in. I have y minus y1 is 6 equals my slope of -3, and then x minus my x1 value of -2. Now we're going to, so this is point slope form. So if you were asked to identify point slope form, this would be what you would give us. And now we are going to convert it by distributing first the -3. And then we're going to add 6 to both sides to isolate y. And we have y equals -3x plus 0. But I'm not going to write the 0, just leave it like that. This means that I have a slope of -3, And my y-intercept is the origin, 0, 0. So my b value is 0, 0. We have x1, y1, x2, y2. Let's find slope. -2 minus -6, that's the vertical change. Then we have 12 minus 4, the horizontal change. So the rise is going to be 4. The run is going to be 8. So our slope is 1/2. I'm going to use this first ordered pair to be my y1 and x1 value. So we have y minus the y1 value of -6 is equal to my slope 1/2 times x minus the x1 value. Clean it up a bit. And this is point-slope form. Now let's convert it to slope-intercept form. Distribute the 1/2. Subtract 6 from both sides. And I get y equals 1/2 x minus 8. So my slope is 1/2 and my b is 0, -8.